This is section 7-3 notes on factoring part 2. This also comes from section 5.4 of the book. So we want to factor this completely now. So we have to bring it down to its lowest degree. Right now it's a fourth degree polynomial. There's no greatest common factor in 16 and 81. So actually there is at least, nope, there's nothing in common. So this is actually a difference of squares pattern. So we take the square root of 16x to the 4, which is 4x squared. We take the square root of 81, which is 9. And then we have one solution is plus, and one solution is minus. 4x squared minus 9. And we have to keep going. So this was the difference of squares pattern. This is the sum, so we can't factor that anymore, but we can factor this. And so this is 2x plus 3 and 2x minus 3. So the final solution is this. There are 3 factors. We can't take it any further. Number 2, we actually have a greatest common factor here. So we can take out at least 2 p's. So we have 2p squared that we can factor out. And then, so if we divide this into each term, we get p to the 6th plus 5p cubed plus 6. And you can always double check your answer by distributing this back out. So 2p squared times p to the 6th is 2p to the 8th. 2p squared times 5p cubed is 10p to the 5th. And then you have, this is minus, so this should be minus 6, but we're actually going to change this to be plus. So go ahead and change that on your notes. So this will be plus 6. And so then we do, but this is a trinomial that we can factor. So we leave our 2p squared here. We set up our terms here. P to the 6th is p cubed times p cubed. And 6 is what multiplies to 6 and adds to 5. Well, that's 3 and 2. So you have plus 3 and plus 2. And so this is your final answer. This should be a plus here. Okay, find the real number solutions. Now we have to not only, so that was just factoring. Notice there's no answer for x or answer for p. It's just broken down into different parts. So now we're going to actually find the solution. So we have to factor it first and then solve it. So again, we look for the greatest common factor. There's definitely an x in everything, and a 4 divides into everything as well. So we're going to take that out first to make our lives easier. So we take that out and we get 4x divides into 4x to the 5th, x to the 4th times. This divides in, so you get minus 10x squared and then plus 9. And it still equals 0. See, these are equations. That's why we can find solutions. These up here were just expressions. So we have this, and we are going to keep factoring. So I guess you can do the diamond problem on these, but we're normally just going to take the square root here. So we have 4x, and then the square root of x to the 4 is x squared. And I can tell that's right because the middle term has an x squared in it. And then what multiplies to 9 and adds to negative 10? Well, that's negative 1 and negative 9. And now we have 2 factors that are difference of squares. So if we really factor it all the way down, we would keep going, but we can stop here and just write an equation for each term. It's actually easier to find the solutions. Or we could do this. This is difference of squares, so it's x minus 1 times x plus 1. And then we factor this, and it's x plus 3 times x minus 3. So then we are left with, let's just move this down here if we can. Maybe not. Let's move this down a little bit. Oops, we took the x with us. Let's erase that. Okay, that's an x. So our final answer is x equals, well, it's 0 here. 0 makes 4x equal to 0. 1 works here, and -1 works here. And 3 works there, and this is x minus 3, x plus 3, so -3. So our answers are, there are actually 5 solutions, and it is not a coincidence that the degree of this is degree 5. So we can write this more succinctly like this: x equals 0, plus or minus 1, plus or minus 3. And that gives us all 5 solutions. Okay, here we are, number 4. Let's pull up a different color here. Okay, so the first thing we have to do is get this equal to 0. That is the very first thing we need to do, and put it in standard form, which means descending degrees. So minus that, plus 24x equals 0. Okay, and then we always look for the GCF first, which is 2x. So we take that out, and what's left over is x to the 4 minus 7x squared plus 12. And now we can just do a diamond problem for this, 2x, and we have the square root of x4 is x squared, so x squared and x squared, what multiplies to 12 and adds to -7, -4, and -3. And now I'll do this a little bit differently. Instead of completely factoring it, I'm just going to write 3 equations and set each equal to 0. And x squared minus 3 equals 0. And I'm going to solve it. This is what we always do. This is not a new trick. So if you solve this, you get x equals 0. That's one solution. If you solve this, you get x squared equals 4, and you take the square root of each side. So plus or minus the square root of 4, which is plus or minus 2. And the same thing happens here. So we get x equals plus or minus the square root of 3. And we leave it the square root of 3. So our bottom line here is that x is 0, or plus or minus 2, or plus or minus the square root of 3. So we've got 5 total solutions. The degree is also 5. And let's back up here. Okay, those are the ones where we've solved it. So let's try this one, number 5. Let's try this in blue. So step number 1, get everything equal to 0. So we have 6x to the 4th, because we add that to each side. We leave the minus 27x cubed plus 15x squared, and all that equals 0. Now we have to take out the GCF, so it is 3x squared. We don't want to deal with that if we can take it out. So if you think of dividing this into each term, 3 goes into 6 twice, x squared goes into x to the 4th, x squared, and this is minus 9x, and then plus 5. So we've taken out the GCF, and then we are going to set each factor equal to 0 and solve. So we'll set, this one's easy, right? 3x squared equals 0. And when we solve, we get x equals 0 there. Divide by 3 0 over 3 is just 0. Take the square root of 0, it's still 0. And we don't need to say plus or minus 0. It's just 0. This, okay, so we're trying to factor this. So let's review that. If we do the full process, we want to break the middle term into 2. So we multiply the first and last terms, and that gives us 10x squared. And then the middle term goes on the bottom. And so we'll say, what multiplies to positive 10 and adds to negative 9? And you can keep trying, but you're not going to get anything. So does that mean you can't solve it? No, it doesn't. It means you use the quadratic formula or you complete the square. But the quadratic formula is easier. So we have x equals negative b plus or minus the square root of b squared minus 4ac or ac and then all over 2a. All over 2a. So we just have to simplify this just. So this gives us positive 9 plus or minus square root of 81 minus 40 over 4. And we're almost there. So 9 plus or minus the square root of 41 over 4. So these are my other solutions. Now how do I know I'm done? Well, the square root of 41 is prime, so there's no perfect squares in there that I could pull out. So I'm done.